culture of milkfish. The milkfish has more than a century's history in Taiwan. From open sea fishing until the present day's inland culture, milkfish enjoy the greatest area space and production volume in the island nation's culture industry. Given such a scale, it has been a critical element to the economic development of farming villages and over the years, long ingrained in the lives of farming and fishing towns. The market demand for milkfish is rather considerable. Nonetheless, for all the years of research on the artificial culture of milkfish worldwide, none had proved to be successful until the year 1977, when the spawn fish caught in nature were used to cultivate fry. The method has sustained the culture technology for milkfish, despite which natural spawn fish are scarce, and it is particularly difficult to use the ones caught inshore for breeding. In 1979, injection, egg harvesting, fertilization, and spawning were initiated, which paved the foundation for massive artificial culture of milkfish. Milkfish are widely distributed in the Indian and Pacific Ocean and produced in Taiwan, the Philippines, and Indonesia. Milkfish are a warm water fish. They generally habituate in the open sea, and during the reproduction period, they circle round the coasts. The species survives in a wide range of temperatures. The lethal temperature is 8.5 degrees centigrade when paralysis occurs, and the highest lethal temperature is 43 degrees centigrade. Milkfish also have a great tolerance for salt content and a resistance against a low oxygen environment. In terms of diet, the mouth of the milkfish is small and without teeth, and the gills are dense. They are herbivorous fish. The young ones mainly live on Bacillar pinnata, and when they reach 35 centimeters, the grown fish survive on green algae, aquatic plants, as well as some cyanophyta and organic bits. When grown fish reach about 1 meter in length, the reproductive gland begins to mature. Full maturity is reached by 6 to 9 years of age and mostly by 8 to 9 years old. The preferred mother fish size is over 3 kilograms, and generally those of better maturity can be harvested during the spawning season. They are then delivered to the spawning site. For short distance transport, black plastic bags filled with oxygen will suffice. In transport, ice packs are placed in the water to keep the temperature low, and pure oxygen is used. Before stimulating spawning, salinity adaptation is administered at the latter rate of 1 to 4% per hour until salinity reaches 35%. The fertilized eggs are placed in plastic tank of 500-liter capacity for spawning in seawater. The temperature should be controlled in the range of 29 to 31 degrees Celsius. Use fine woven nets to take out the eggs naturally laid in the tank and place in another tank of 500-liter capacity with oxygen pumped into it for spawning. Fully spawned fry can be expected in about 30 hours after fertilization. If the eggs remain in the spawning state 33 hours after fertilization, it is an indication of irregularity, and the batch should be discarded. The feeds for young milkfish include chlorococci and artificial feeds. Newly spawned fry have large yolk sacs. At this stage, the fins are not yet divided, and black pigment can be observed on the black ridge and belly. The fry are cultivated in aerated environments, and the process is as follows. The first or second days, cultivate fertilized eggs of green water and oysters. Third day, from the 3rd to the 10th day, chlorella, Isochrysis galbana, Brachionis, Plicatillus, now Plius, Tigriopus, all can be used as feed. 4th day, the first dangerous period for fry. 11th to 21st day, mixture of Brachionis, Plicatillus, Artemia, Salina, Tigriopus, all can be used as feed. Thereafter, continue to feed with Chlorophyta and Bacillari panaita. Milkfish are cultivated in large capacities in Taiwan, the Philippines, and Indonesia, with rather high production volumes. For the uncertainty of natural spawn source, the culture is limited to the aforementioned regions. Taiwan has a longer history in cultivating milkfish. The common practice is fertilizing large ponds for breeding floor algae in cultivating milkfish. With proper environmental conditions, strong, healthy mother fish, and means of generating the maturity of the reproductive gland, natural spawning in ponds is possible. Massive fry can be harvested through such means. Milkfish spawn's fertilization rate in water of different sodium contents does not vary greatly, 10 to 18%. However, it is referred. For lack of natural feed, artificial feed for later stage fry is mainly designed according to the grown fish nutrition requirements. The protein requirement is 40 to 50%, and the survival rate is in the range of 40 to 90%. Milkfish are cultivated for two purposes. One is food product, and the other is as bait for tuna longline. The primary culture formats comprise ponds, including conventional shallow pond culture and the recently developed semi-refined deep pond culture, net-fenced and experimental cage net culture as well. At the same time, repair pond ridges, floodgates, and chutes. Taiwan culture is mainly undertaken in two formats, shallow and deep water culture. The method must overcome the difficulty of fry spawning season and climate. Temperature maintenance is the challenging aspect for shallow water practices. When the cold fronts strike the southern part of Taiwan, the water temperature is often lowered to less than 8 degrees Celsius, resulting in massive death rates. Consequently, fry that cannot reach marketable size after pond cleaning in the winter season must be preserved through the winter. The regular method is facilitating deep water ditches with wind fences to maintain water temperature. This is known as water canals. The fry that cannot be marketed in the winter are kept in the ditches until the water temperature warms up in the coming year. Nonetheless, the ditch's insulation capacity is limited. When fierce cold fronts attack, the drastic fall of water temperature often frees milkfish to death. Moreover, the ditch's high fry density also leads to water deterioration, fish body injury, diseases, and pesticides. These are also critical factors to milkfish mortality and are the major barriers to conventional milkfish culture. Differing from the conventional shallow pond method, deep water intensive culture uses artificial feeds. Consequently, it does not require sufficient sunlight for breeding algae. Generally, the water is more than 2 meters in depth, which is fully utilized. Practices include freshwater, semi-seawater, seawater, but the ponds are mostly freshwater based, deriving water sources from groundwater or rainfall. To enhance culture density and manpower cost savings, the ponds are facilitated with feeding machines, water wheels, or aerators. Compared to the shallow water format, the breeding density increases with the water depth ratio. However, the pond environment and equipment conditions should also be taken into account. Food mostly comes from artificial feeds. A hectare can accommodate up to 25,000 fish with a production rate of 11,760 kilograms a hectare. That is about 5 times the rate of shallow water ponds. The artificial feed for milkfish contains 23 to 29% protein, and the meat increase coefficient is 1.5 to 2.2. In using artificial feed, bait adaptation is required in the initial stage. For bait adaptation, feed is thrown in fixed locations, starting from small volumes and increasing gradually until the fish are able to gather. Feed volume is determined by fish size. The feed volume should be adjusted according to fish intake and water temperature. Automatic feed dispensers can administer designed feed volume at the preset time. That saves on manpower and minimizes waste of feed. Feed costs for deep water intensive culture is high, and the electricity for water wheels also increases the cost. 1. Preparatory work. Before release, ponds shall be drained dry. Aged ponds must be cleared of organic substances deposited at the bottom, and the embankment shall be repaired before allowing the sun to bake the bottom dry until it cracks, so that the sludge at the bottom can be fully oxidized. In addition, depending upon the age degree, 800 to 1,000 kilograms per hectare of lime can be sprinkled for sterilization, as well as generating the decomposition of the organic substances. New ponds, however, require no lime for sterilization. 2. Release. After the ponds have been cleaned, fill water until 1.5 to 2 meters in depth. Wait for 5 to 6 days before release. At this time, the ponds will contain large amounts of protozoan as food for the fry. Milkfish fry should be bred for about 20 days before releasing into the ponds. For initial release, fence off a corner of the pond with green mesh net for accommodating the fry. Let them adapt to the bait for some time before removing the net. Furthermore, in cultivating large fry, charge of water shall be administered or facilitated with propeller machine. The following management issues should be heeded during the culture period. 1. Make daily rounds of the pond to prevent the water from being overly fertilized or becoming milky. The transparency of the pond water should be around 30 centimeters. 2. Do not use single feed on a long-term basis. Add appropriate amounts of vitamins and minerals to feed regularly to meet with the normal nutritional needs. 3. The fry size before release should be uniform. 2 months after release, separation by size should be carried out in the morning of fine weather. 3. Water quality management. During the fry stage, the water color is best kept clear with bottom visibility, and light green or brown is preferred for generating the grown fish's appetite. If the water is too clear at this stage, the feeding will not be quite as satisfactory. When the water turns dark brown, replace it at once. Failing to do so will result in a massive death. The mouth edge and tail will turn white, and the milkfish will float on the surface with its mouth open. As the area of milkfish fry supply is limited, culture is only practiced in Taiwan and in the Hainan area. However, given the species' strong sodium tolerance, they have also been spotted in the fishing harbors further north. This proves that once the fry problem is resolved, culture can be expanded to Canton, Fujian, or even Jiangsu areas. Moreover, given that milkfish can be cultivated independently or in a mixture, the future of incorporation with prawn culture is rather promising. With the milkfish's herbivorous diet, the feed in prawn ponds can be effectively used in increasing productivity. Because milkfish can be kept singly or in a mixed culture, especially with shrimp inside the mixed culture, the prospect is considerable for growth. Make use of the milkfish feed to plant bait is the main characteristic. It can reasonably make use of and keep the bait in the shrimp pond and attain to boost production for that purpose. In addition, this province can keep the culture of milkfish edible method than oneness. The future should develop more process, the product, and make sightseeing trip leisure food.